Good afternoon. If you're watching this after the fact, check the notes. The description down below has time codes. We probably won't get going immediately here, so that'll let you know about what's going on. We'll say some hellos as everything gets going and people get alerted. And I stop my windows and all that. Thanks to JP for streaming before me, and hope everybody enjoyed that. I always like the tunes coming from JP. It seems like ages ago that I visited. Live on YouTube. Thank you, Mr. Certainly. Hello to Dave Odessa. Good afternoon, evening. Hello, Patrick Rankin, and hello, Gadgetoid. Hi, Toddbot. Hi, Hugo. The cat looks like she wants to go out. Should I let her out or make her stay in here? I'll kick her out. Go out. Here you go. Whatever you wanted. She's going to go beg in the kitchen. Mr. Certainly says, good afternoon, Scott. How are you doing? I'm doing good. Yeah, I got most of what I wanted to get done this week. I'm taking tomorrow off to go ski, which doesn't look too bad in terms of weather and snow. So hopefully that'll be fun. It'll be during the week, which is really nice. So hopefully it won't be too busy. Hi, Kinger North. Hi, Bruce. Hi, Jay for seeing. Yeah, pretty good. My week's just about up, which is great. I've got a preview of what we're doing today. I got my box of iMX parts. We're gonna take a look at that probably. Good. I think I got everything set up. Let's see. Did I forget anything? You can hear me. I set the titles. I made the note stock. And I have time codes going. Awesome. Let me move this over. Before we get started, let me just get everything. Oh, that's like perfect. Awesome. Okay. I was just talking about the Game Boy cart. I want to do... Oh, yeah, unboxing. Did I say I was going to do an unboxing? You know, I did all the flash chips already. But I can go get the other things. There was some other stuff in there that I don't actually remember what it was. So let me go get that before I do housekeeping. Hi, Beta Graph. Hi, David G. Hi, Jim. iMX unboxing, but yes, you have a bag of stuff too. It's true. Yeah, I think I got all the cameras going as well. So let's get this party started. Hugo says there was a big old box of digikey goodies you showed last night. Yes, I did. And I can talk about that. So let's do housekeeping and get the show on the road here. I'll take a time code. I'm not sure David's around because David works on Thursdays, I think. David who takes notes. So I'll do my best to keep up with that. So hello, everyone. Let me switch to the camera. My name is Scott, and I work on Circuitpython for Adafruit. Circuitpython is an easy-to-use version of Python designed for microcontrollers. They're little, tiny, inexpensive computers. Let's see, what do I have here? Ooh, I've got a special thing courtesy of Paul Stoffergren. I'll show. This is one example of a microcontroller here. This is a Teensy 4.1, I believe. It's either a Teensy 4.1 or 4.0. But on here is a really fast... it's a really fast microcontroller. It runs at 600 megahertz, which is kind of insane. but we're starting to dust off some work we've done on the iMX RT, which is this chip family for CircuitPython. So we can talk about that today. But the goal is to get people programming with electronics really quickly. So that's what CircuitPython is. If you have questions, this is a great place to ask questions. I'm always happy to answer them. I work for Adafruit. So Adafruit is an open source hardware and software company based out of New York. I live and work in Seattle, so this is my house. So I'm Pacific time zone, and that's the dealio. If you want to chat with me and a bunch of others, Discord is a great place to do it. We have an Adafruit Discord server, which is adafru.it/discord. So if you're not on there, we highly recommend it. If you're in any of the other video chats, it like goes away at the end. So this is Discord's great because it doesn't. So yeah, check that out. This is a deep dive. They normally are at Fridays at 2 p.m., but I'm going skiing tomorrow for the last time this winter. So, well, it's spring now, but for the last time. So today's Thursday. This is kind of my backup day, my backup time. It's the same time, just a day earlier. Typically we go for 2 hours. Questions are welcome. We've known to wander a bit and just try different things. So I see some of those are getting queued up, which is great. We'll talk about those, and I'll take time codes I'll try to take time codes as I answer any questions. Next week will be on Friday as well. I looked at my calendar. Friday should work. And then a heads up, and if you have ideas, let me know. It's actually the 1-year streaming anniversary for deep dives in 2 weeks. On the 9th. I think when I started doing it regularly was April 10th of last year. So I think we should call it a 1-year anniversary in 2 weeks on the April 9th. I'm also speaking at the Open Hardware Summit in the morning, speaking on interface design, and particular PID numbering is going to be a topic of that. So I'm excited. I'm happy that I got accepted to speak at the Open Hardware Summit, which is exciting as well. Last piece of housekeeping before we start answering questions is we do have Cat Cam here. This is Spook. He loves to sleep in the sun. He is epileptic, so just beware of that. He may have a seizure, and if I'm like on screen but not paying attention, just making sure he's okay. He's been doing really well, so I don't expect that to happen. As some of you know who were watching last week, he went to the vet. He got a mostly clean bill of health. They had told me last time he went to the vet as well that they heard a slight heart murmur. But he's been doing so well, we're gonna just monitor it and see how he does. But besides that, he's doing well. They like his weight and everything, so good for him. And that's housekeeping. So usually we start with questions. Hello, or I'll do some hellos as well here. So Andrew Reed says hi from Cornwall. Hi, Andrew. I think it said hi to Jim. And yeah, we can just do, David was like unboxing of just this box of all the iMX chips I have. I think that's a great idea, so I'll do that. Hugo says there was a big old box of digikey goodies you showed last night. Yep. I have the box here, but I've actually, like, the vast majority of those bags were actually, they were flash chips, because I've been cataloging flash chips. So let me just show you. Hi, Keith E. asks, how's it going? It's going good. Cat news. Congrats on 1 year deep dives. I guess I could probably pet Spook from here, but I'll do that at the end like I normally do. I might have to sneeze here too. We'll see. So, this is, oh, you can't see. I see. Thank you to whomever asked a question in the doc. I will get to it. But since we were talking about the unboxing, I just kind of want to cover that first. So, let's see. DigiKey order. So I made a big order from DigiKey, and mostly what I had is actually flash chips. Oh yeah, if somebody's... David says Gadgetoids in the Facebook chat. I don't watch the Facebook chat, so if that's working, I encourage you to go somewhere else. and do that. I don't monitor the Facebook chat. I can't promise you anything. Discord's much better. adafru.it/discord. Okay, so here's what I have. This system is. I showed this on Show and Tell, but I'll reiterate it in case folks have questions. But what I have is these. I've got these. I've got 3 boxes of these Boxall AidTech boxes, and I just take stickers I have. I have a SparkFun. I had a SparkFun sticker from the Osh Park goodie bag, so I put that on there. I just use stickers as a way to know on the outside which box is which. And then what I do is in fact, let me use the overhead here because I know Mr. Certainly wanted to know how well they work. So let's go to the overhead and I'll zoom it out and move this. My desk is filling up here, but let me just show. So here's one of the boxes. It's not. If it gets too bright, that'll be bad. So there's a latch on the end, and then when you open it, it's all these little compartments. It's actually designed for SMD components. And the way that I have it set up is, let me flip. There we go. So here you can see that I've got kind of like battleship style, like letters this way and numbers this way, and it actually matches up with spreadsheets. So I don't actually mark the individual components. What I do is I have this Google Doc that tells me what compartment everything is in. So let me just show you, like, this is G4, and you can like hear that it's like got some pretty stiff action, which is good. And this is just one example of what I have in here. I have a flat flex connector things. Oh, that's a chunky click. I like it. Yeah, it is. The one time that I know you asked this yesterday, I did find that if it's a little too full, it can not snap quite as well. But I've been using these actually quite a while. I just started filling up these other 2, but this one I've been using a lot because it's got, like, all my resistors are up here, and then all my capacitors are up here, and all my resistors are here. So it makes it really easy if I'm hand assembling something. So yeah, I really like this system. And then let me switch to the desktop. I'll show you. So most of what was in, how many openings are guaranteed by the vendor? I have no idea. It's just, I bought it off Amazon, and I think I've shared it enough. Hopefully folks can share that again. They're like reasonably priced, and it's a lot of compartments for the price as well. Like it's, let's see, it's 12 tall times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's like 144 different compartments, and you can buy a 2-pack of the one here, and then there's also one that has, the bottom is the same size, but then the top is these like chunkier compartments, and I'll just, like, they're still, hi Muhabin, like they're still pretty snappy here, which I'm pretty happy with. And I just, like, there's so much packaging, especially when you buy like something from digikey where it's just like 3 parts. Like, you can take like a bag and another bag and just reduce it down to one of these compartments pretty easily. So the way that I have it here is, let me switch to the desktop. If you look here, these are all flash chips. Actually, the flash chips start here. And like all of these I ordered in that last digikey order. So it's like 32 rows of flash chips, although there's like a couple other things in here that aren't flash chips. And I actually put the RP2040s that I got from Lamore in there as well. So I got like 24 flash chips in here. I did just make an Adafruit order for another one of the sockets. I was going to solder them all down. And then I decided I didn't really want to do that. Because 10 says I really need this organizer. Yeah, these are great. I'm very happy with these. I don't know, maybe we'll stock them. I don't know. I think Lamore's reaction was also that of like, oh, I want some of those as well. Like we have the individual boxes that like snap together, but like these ones are great because they're like um David G says RAID array of flash chips. So actually, it turns out I was looking at the iMX, and the iMX can do 2 parallel flash chips to be able to load a byte at a time rather than just a half byte or 4 bits, which is cool. Hugo says I'm much more interested in how many times they'll close without reopening on their own. Yeah, I mean I've been using this one for a while and it hasn't happened to me yet. I haven't find it open. I know what you're talking about because for Spook we have like a pill organizer and like we have issues with that. But that's also one thing where you like push down and it pops out. Okay. And oh, the last thing I should show is that I have this printout that I do, and I need to make this better. It's not working right now actually, but it's a grid that matches up with the organizer, so I can print this out and then look, like have a reference of what all is in a particular like compartment in the organizer. But it's actually broken now that I have multiple boxes. The thing here that I'm using doesn't work for multiple boxes, so I got to figure that out. Okay. So that is mostly what I had in the digikey order. Let me just wrap that up. Let me show you the other stuff. So after I went through all the flashes, I think this is all the remainder that I got. So I'll put it under the overhead and put this stuff on the floor. And I realize you can't see the overhead. Mohammed, I see your question. I'll get to it in just a sec. Pivot table filter on the box number. I don't know how to do a pivot table filter. I do have a column for the name of the box that can match up. Okay, so let me hit the focus lock button. And then I'll show you what I got here. So this first thing here is MCU link, and I'll just open it up. I don't need this extra bag. This, because we're just starting to do iMX again, this is basically like the ST-Link equivalent for the iMX. So MCU link, and I haven't even tried to use it. I probably won't actually use it, but it's a programmer board, and you can see the quick reference here. So it does SWD stuff for the iMX things. Oh, and it's super tiny. Ha! Look at that. I thought it was going to be... Why would you put it in a giant box if it's just that big? Let me see. What do I have to compare it to? Here's that, and here's a Pico for comparison. So it's like not much bigger than a Pico, just a little fatter. So that's their like ST-Link sort of thing. Have I seen Unexpected Maker's voice inventory system for reals? I think I did. And this is just a cable. This is in the box as well. But generally, I like to get rid of packaging like this. I don't have all that much space, so any space I can recover by getting rid of stuff, it's a benefit. So that's one thing I got. I'll toss that too. Pico is the new banana for scale. That was just like top of my... I have like a bin full of stuff here. Okay, I'm caught up on Discord. So let's see, what do I have here? Oh, I have 2 Seesaws. I actually order some stuff from Adafruit sometime, or like Adafruit boards from digikey if I'm making a digikey order, and I just pay for it. Sometimes they reimburse me for orders, but sometimes I just buy them anyway and just write them off as a business expense. So I got 2 Seesaws because I want to experiment with this idea of doing a control surface where the different pieces of the control surface are like SAMD09s or SAMD10s, and then they're actually multiple. Each of those chips can control a shared I2C bus, And then there's one device on the I2C bus that like they all write to gather all their information. Han said, "Hi all, I received my Feather RP2040s in the Netherlands within the week. Amazing. Awesome." Emmett says, designing a circuit board. I don't, I do occasionally. My job is not to, where am I with time codes? I should at least do it occasionally. digikey order. I guess we're doing that. But I'll do designing a. So I actually did design a lot of PCBs before I started at Adafruit. I was starting to do my own like flight controller for drone business, and so I kind of like I started this spreadsheet when I was doing that, and then now I pick up parts and dev boards just to have them in case I need them. So like I bought a bunch of flash chips, and so having a way to catalog and keep those in a dense storage is really good. So this is a dev board I picked up to prove my point. It's for the XMC 1100 eval, and it's an Infineon microcontroller. It's a Cortex M0, and this is an alternative to the SAMD09, basically. It's like less than $1. I don't think it has USB, but like I'm thinking about this like using really inexpensive microcontrollers simply over I2C, not over anything else. So I picked one of those up. And that will go in maybe this iMX box, or I do have another box. It's like a nice tiny board, very similar to like the Seesaw size. It's always funny to see that like the like USB to serial converter is likely this chip, and then this chip is the tiny one that the dev board's actually for, and it's even got like a keychain on it, which is funny. So yeah, I'm thinking about that, especially because we're starting to do some keyboard stuff. And I like this idea of doing like keyboards and sliders and rotary encoders and stuff like that. And then some more Adafruit boards I bought from digikey. These are the SOIC 16 breakouts, TSOP 16 breakouts. And these are for, one of the flash chips I was able to buy is actually a 16-pin version instead of the 8-pin version, so I got some of those. And the last thing I got from digikey is a bunch of the 8-pin breakouts from Adafruit, which I thought I would solder them all down, but I don't think I'm going to do that. I just ordered a new socket to put on one of these, and then I'll just pop it in. Vitagraph says, curious about the I2C stuff. Yeah, it's just an idea I have. It's not my Adafruit work, so I don't know when I'll do it. But I like the idea of like, if you have a control service with a bunch of micros that are like keeping track of rotary encoders and all that stuff, like you can either pull them all and see like that a lot has not changed, because if you have like 10 like things that are controls that you've like merged together to make one control surface, like your hands limit how many things can change at once. And so I was thinking instead what you could do is you can have them all 10 of those things control a shared I2C bus, and the SAMD's I2C things can know if you get collided against. So basically like you risk getting your I2C transaction corrupted, but it means that you only transmit over the I2C as you need it. Which is really interesting to me, so I might do that. So let me go back to a couple of the questions here. So Mohammed asks how to configure the UART receive interrupt in Circuitpython. So Circuitpython doesn't expose interrupts, and my follow-up question would be, what are you trying to do? Because the way that we have UART set up in CircuitPython is that when you create a UART class, a UART object, you tell it how much data it should buffer on your behalf. And internally, it will use an interrupt to make sure that it buffers that into memory. And then from Python, you just read from that buffer of whatever length you made and read it as it comes in. So I'm curious what you're trying to do. where you need that. And if you follow up, I can continue talking about that. How is everybody liking their Feather RP2040s? Juan Carlos says, "Hi Scott and all, glad you're streaming on Thursday as I just got my Feather RP2040, so it's perfect timing." David G says, "I have a Seesaw since more than a year and I still don't know what the use of that is." Yeah, part of that I think was that like Dean was doing a lot of it, but Dean left Adafruit, so it was it may not have been continued after that. Mohammed says, "I'm using a smart HMI screen which sends touch data over UART." You should be able to just read it as it comes in. I don't know why you need an interrupt to do that. You just need to like poll, you need to query if things have come in. Okay, there's one other question in here. So let me hit that. So the question is, and I don't know who put this in the doc, but thank you for putting it in the doc. USB host is supported on the Teensy 4.1. Plan to support it in CircuitPython. In the long term, I would like us to expose a host API. That's for sure. I think most of the work is actually on the like what is the API from CircuitPython to show USB host, because I think TinyUSB has basic USB host support already. So Dan is going to be doing more work on USB in terms of dynamic USB descriptors. So that's still device side. But maybe after that, we would want to do USB host. But I'm not super sure. So Hugo asks, let me take a time code. Hopefully I haven't drifted too much. I'm like 8 seconds fast. Yeah, Toddbot says TinyUSB's host mode driver is pretty basic at the moment. And also Foamy Guy points out that Winterbloom has a hostess feather wing. So what I was going to answer is, what is the intended purpose of Seesaw? So the Seesaw was something that we did originally, I believe, with Cricket. And the idea was kind of like a bit going back to the roots of what microcontrollers are traditionally used for, which is it's used for offloading real-time things to other things. And the reason that we did it for Cricket was that we wanted to have Crickets for both like a SAMD 51, but also wanted it for a Raspberry Pi. And so by having a smaller, inexpensive microcontroller that can handle ins and outs and do analog as well, that was kind of that. One thing that I would like Seesaw as it is now kind of has like one fixed firmware that does everything. And I think the route that I would like to explore is actually I2C bootloader, where it's more this, what we talked about with coprocessors and CircuitPython in general, of like CircuitPython is responsible for saying, okay, hello, this thing, run this code now. And then it runs that. So that's kind of what I was interested in. It's probably pretty far down on my list to actually do, but couldn't help myself and pick up a couple that. Yeah, David G says, what? The Seesaw does not run CircuitPython? Correct. It does not. Johnny, hello Johnny, says, I didn't miss any iMX content. We talked about it just a little bit, but not a ton. So I think let's like a port expander via firmware on a SAMD21 coprocessor rather than a specialized chip. Exactly. And in fact, a lot of IO expanders that you see, like they're actually more expensive than just an inexpensive microcontroller. Because the advantage of inexpensive microcontrollers is that they can do a lot of different things because they change with software. Oh, great question. Another one from Hugo. And this is probably something that we'll talk more about next week as I get into Bluetooth stuff. But Hugo asked, what are such would be the major milestones to get a Bluetooth-only experience working on a CircuitPython device? So this is actually my plan to do. My plan is to start next week on it. This iMX stuff is just a bit of a detour. It's a detour because Jeff is primarily doing the iMX work, but because I was just doing all this Flash stuff, we wanted to change the Flash settings for the iMX thing to use the nvm.toml stuff as well. So that's why I'm taking a slight detour into iMX, is just to get the Flash stuff going, which is why I have my collection of boards here to test the Flash stuff on, because I actually got it compiling. We'll see if it works, and I got to remember how to actually load code and things like that. But so what I'm thinking about, and we can talk more about this next week, but the big items I'm thinking about are like, so for those of you who don't know what BLE workflow is I want to be able to use CircuitPython from a phone or a tablet without USB, particularly because like the microbit V2 here, which I've had on my desk for months, doesn't expose the USB link, at least so we couldn't do a CircuitPy drive. And so one of the things I want to do is a BLE workflow. And Trevor is on vacation this week, which is good, but next week is on Friday. So Trevor started working on an app that just allows you to push Python files to the device. And so we need to figure out some stuff. So I was talking about Dan about this, but starting from the beginning, we need a way to. So I had early on when we did NRF for CircuitPython, I had it where we actually did have a file system, like BLE service or a server that we made available, so a client could push code to it. But we were about to, before PyCon got canceled, we were talking about doing a giveaway at PyCon of BLE devices, and that kind of forced me to realize that like we weren't secure at all in terms of how you connect your phone with your device and make sure no one else can. And in an environment like a classroom or a conference, like you want to be pretty, like you want to have a plan for not perfect security, but like deliberate pairing between your device and your phone and the device itself, because you could load and like read and write code. So the first thing to do, or one thing on my mind, is like we had this original stuff, but it's turned off, and so it's probably bit rotted a bit, where it's like if I turn it on, it won't compile and it won't work. And part of that is like we were preserving, like right now we shut down the Bluetooth stack until you import BLEIO, I think. And so there is going to be some work of like, no, we want it running all the time, because you want to basically get the error output and still stay connected even if user code's not running. So there's that work. And then there's this whole process of coming up with like, how do I connect to my device? And I think there will be kind of two categories. There will be devices that do USB and BLE. And in that case, they just start up and assume you're doing USB. And then there's also BLE only CircuitPython devices. And those, if no one's ever paired with them or no one's ever bonded with them, which is the term for like sharing identification, like authentication stuff so that you can reconnect later without intervention. So if it's BLE only, you start up, you say, I've never been bonded, so let me start advertising that I'm here. And then on your phone side, you could say, look, is there anything I can connect to? And then how do you confirm that like it's not somebody over there with a phone that's trying to connect faster than I am? So there's going to hopefully be a little bit of a process to like collaborate or coordinate between the two devices to say like, yeah, this is what we want. So that's how you get bonded in the BLE only case. And then in the USB and BLE only case, or in the case that you want to rebond, I think there is also going to be a startup period. Like we kind of do this already, where like if you double click really fast, you get the bootloader. If you double click slower, you get the safe mode. And then I think after that, if you click even slower, there will be a period where like the status LED is blue, and then like you hit it when it's blue, and that means that like okay, go into pairing mode. So those are kind of some big things in the like user experience side, and there's things that you can do potentially that we can do with the advertising that happens at that point as well. Of like, not only do we advertise like an Adafruit identifier, but we actually advertise like a board identifier, so that if we can like actually show you a list of boards we see, we show pictures of the boards, not just names of the boards. And then even potentially for some boards that have like lights and stuff, we could coordinate like what pattern they're doing, so that you can confirm that the thing that you're connecting to is the one that you want potentially. So lots to explore there. And then on the like once you're bonded, then it's a matter of like I want to do an iteration on the BLE server that like allows you to read and write files. And there's like at least one kind of example, but I don't think it's really complicated. There's a lot of details, so I want something simpler. But one of the requirements for the server for files that I want to do is when you're sending files back and forth, I want the receiver to be able to say, hey, I've got this much space, send me this much data. Because we don't have a lot of RAM on some of these devices, and so I want to say like, just give me 512 bytes, and like it'll slow down the transfer, but it means that we don't have to buffer a lot on the device side. Because like imagine you're a Circuit Playground Bluefruit and you're trying to write to your flash. Like when you're writing to flash, you have to go through these erase phases, and that can take a while. So you don't want to have to accumulate a lot of data while you're doing an erase. So yeah. Keith E says, so is that over an HCI protocol? I'm not familiar with Bluetooth, just have been trying to pair / bond my Wii balance board to a Raspberry Pi, so this is somewhat familiar. So HCI is usually... HCI in BLE terms is host controller interface. And so this is the idea that there's like... Your Raspberry Pi actually uses a separate chip for Bluetooth. So there's a Bluetooth controller chip on the Raspberry Pi, and then the host stack happens on the main, like in Linux on the main thing. So there's the HCI protocol is what is between that host code on the Raspberry Pi and the controller code on the device itself. On something like an NRF 52840, like the host and the controller stuff is all in one chip. Actually, let me take a time code because this is a good... We're getting ahead of ourselves, but that's okay. Now, if you've been paying attention, Dan actually added... we now have AirLift support for Bluetooth. And the way that works is it actually does the host side in CircuitPython and controller side on an ESP32. So we actually have code in CircuitPython that can do the host side of Bluetooth for Central only right now over that. So that could be really cool. And that means that that's probably what we need to be able to do Bluetooth on a Raspberry Pi as well from native CircuitPython. Johnny says, save some Bluetooth talk for next week. Okay, I have one more question for Bluetooth, and then we'll get to the iMX. Hugo asked, and let me just take another time code. Keith EE says that explanation clarifies so many things. Awesome. There's an added tricky thing about HCI in that there's actually different ways you can communicate HCI. So Hugo, the last of Bluetooth is, so would REPL be part of the initial Bluetooth BLE workflow or a later enhancement? It's certainly something that I'll do in that, like, as I'm doing it. And I think it's pretty straightforward because there's a very standard example service that Nordic does called the Nordic UART service. It's super standard. You could use NRF Connect to do it. So my plan is just to implement that for the REPL stuff. So there's a little work in CircuitPython to potentially make it easier to swap like serial streams into that core like CircuitPython serial stream. But yeah, I'll definitely do that as part of it. It probably, if I'm good, it won't be one giant PR. So that may be one piece of it. But yeah. As Patrick says, Scott, this is a great idea and will be huge to get CircuitPython on more devices and for more people to learn to program. Oh, yeah. And also, those of you who like the ESP32, the Bluetooth workflow would allow us to do CircuitPython on that, since it doesn't have native USB. So yeah, it's I'm excited for it too. I'm excited to get to it. I was kind of lobbying to have it related to an ADA box upcoming. I don't know if that's going to be the case, but things that are like in ADA boxes always get a lot of work on them. But we already did an ADA box with a circuit playground Bluefruit, so we kind of already did that. But we have Trevor's time for iOS, so that's really exciting. Okay, final Bluetooth question. Can we do Bluetooth gateway Chinese wall with Bluetooth on the AirLift and Bluetooth on the NRF40? I'm not sure exactly what you mean. I think maybe you mean Bluetooth with other devices, other HCI chips besides. Yeah, I can't help you pair your mouse with your scale. Sorry. Okay. Johnny already bought a Bluetooth board as well. Okay, this is exciting. This is exciting. Let's hold off a little bit. Of course, this is how the stream goes, right? It's like we get excited about stuff when we talk about it. Yeah, Bluetooth's interesting. I'm excited to do it. I'm definitely feeling the hesitancy. Like there's a huge cost for me to there's a huge cost mentally for me switching platforms. Like I've been doing, like when we started, we were doing all ESP32S2 stuff, and then I did RP2040 stuff, and you didn't really see me switch to it because it was secret. But like at this point, I'm switching off RP2040, and so what I've been doing is this flash stuff, and actually we should check. Take a time code. I guess let's not talk about code yet. We just wanted to do an iMX unboxing, didn't we? Okay, so yeah, Gadgetoid says the mental cost of mode switching is tough. Yeah, so I'm like briefly switching to the iMX stuff, and then I'm going to be switching back to NRF for all the Bluetooth stuff. David says, but when all the microprocessors will be supported, what are you going to do? There will always be more than what we support, I guarantee you. And there's always parts of different chips that we don't support. I'm not worried about my job at all. People are going to keep creating new chips because they're upstream. Okay, let's go to the overhead. And maybe I can back out a little further. Let me just show the front again. So what I have here is I have a number of these boxes in the laundry room, which is the room next door, which is also my kind of like workshop. And so this I have labeled iMX. So I don't have a great solution for iMX or for dev board storage. So if somebody has good ideas, let me know. But basically what I've done here is I have, I've just used spare bags and I have stickers on them that tell me what the main chip on the dev board is, which is still nice. So this is the iMX RT1015, and I'll open these up. Here you can see 1062. That's the chip that's on the Teensy. Here's a 1021. 1052. 1011. And I should show the website here. There's the 1011. This is what we'll release a Metro with, which is what we're working on. And in fact, I do have a prototype here. So this is a prototype iMX, although I think it's on the site now. So this is the Metro iMX for the 1011. Johnny says, I bought some RT1010 dev boards when they're released. That's a good idea. I noticed when they release them for $10. They're selling it for $50 now. So you lucked out. Okay, so here's a Teensy 4.1. And then this is actually something like Paul sent me this. So thank you, Paul. And it's actually that all the pins are connected through and there's LEDs on here. He sent it to me as a way to help test that every pin was working. So thank you, Paul. And then I've got a Teensy 4.0 in this bag and a Teensy, looks like both a 4.0 and a 4.1 in this bag. So let me just do an overview of the iMX 1011 line first before we go into, I'll take the dead boards out of the bag and show them off because this is a new platform. Let's take a look at it. But first let's go to the desktop. I just want to highlight this page here. This is just a really, really good resource for understanding all of the different iMX 1010 line or iMX 11 line. And it's just, let me close this. There we go. So this is, I always refer to this page. So there's these two oddball ones, the 500 and the 600. These are like Cortex M33s, and they actually feel very different to me from the other ones. So those I don't really consider. Dylan says, or a wall-mounted pegboard if you're short on space and want to be able to see all the dev boards at once. Old 5 1/4 diskette holders, sorter for storage, maybe. I mean, these are pretty similarly sized, I imagine. Yeah, it's tough because there's like no set order and things. Okay, so we don't really care about these two bottom ones. And then what we can see here is the iMX 1010. It's the smallest version. So package here tells you like not how big the chip is, but like how many pins there are. And generally, if it's the same style package, so like LQFP, it's going to be bigger than the larger the number of pins. So here we can see it's 500 megahertz, 80 pins, 128K of SRAM, 2 I2S, 1 USB. And then the 1015 is very similar, except it has more pins and one more I2S. The 1020, it comes in two sizes, 100 and 144. It has double the RAM, which is pretty exciting. It also has Ethernet and CAN, so that's really cool too. So, and then there's this 1024, and there was initially some excitement about the 1024 because it has this 4 megabyte flash in it, but it turns out this just is like sticking the die of a WinBond chip inside the package. So I don't think we're actually going to do that. Like it's essentially a 1020. It's just that like inside the package is the flash as well, which we'd be excited about if it was a smaller chip, but it's a giant chip still. So the 1024 is not that interesting, and you'll notice I don't have that a dev board for that because it just came out and it's not any different from the 1020 as far as I could tell. So I have. Bruce points at a giant box of stuff. I have a box of similar size, and I have my STM boards and my SAMD boards in that alone. This box is smaller because I have fewer of these. Okay, so this is the 1020s are the highest that we have in LQFP. And then we switched to BGA, and BGA, for folks who don't know, is ball grid array, and that means that the pins are on the bottom side of like the plastic patches. Let me finish this and I'll answer your question, David. So the 1050 is pretty interesting. It's got 512K of SRAM, which is again double what the 1020 has. It also has the beginnings of graphic acceleration, so P by P. I think it's like two-dimensional DMA basically. And then it's got a parallel display interface and parallel camera interface. Same amount of audio, 2 USBs. Oh, and the thing I forgot to say, this USB with PHY is high speed, which means it's 480 megabits per second rather than 12 megabits per second like all of the other boards that we support. So one of the really cool things about this line is the high speed USB. We can imagine you can just shuffle a lot more data across, and the PHY for the high speed USB is built in, so it's not an extra. It's not an extra cost. So, and again, we have Ethernet, we have CAN. So the 1060 here, this is the chip that's on, I don't know why it's 1060 here, but 1062 on the Teensy or on the board you actually get. But this is what's on the Teensy. It's 600 megahertz, a megabyte of SRAM. And then it's got the same graphics stuff and two Ethernet and a CAN FD as well, which I think is a faster version of CAN. And then there's this 1064, and I think this is essentially the same thing. It's a 1060 with a flash in the package. And then lastly, there's this iMX RT 1170. It's 2 cores. It's an M7 and an M4, and the M7 runs at 1 gigahertz, which is obscene. And this is like they advertise this whole line as crossover. So what they mean by that is like there's Cortex M's, which are like real time, just like coprocessors usually, although they're getting stronger and stronger. And then there's Cortex A, which is like the level of CPU that's like running Linux and on your phone. And crossover is this idea of like blurring those two lines. So like STM has a crossover product, but it's a Cortex A, but it's cheaper. Like it's coming this way for crossover, whereas this iMX is going that way for crossover. And you can see that it's like a bigger BGA package. It's got, again, twice the RAM. So it's got 2 megabytes SRAM. It's got a 2D GPU, which I don't remember which one it is, but it can do MIPI as well. And it can do DMIC, which I don't know what it is. More audio, 2x gigabit per second Ethernet, and 3 CAN FD. So this 1170 is like a whole new ball game in terms of this line as well. And I think I've seen on the Teensy forums that like Paul's already looking at the 1170 for like another Teensy. Definitely he likes to live on that performance edge. So this whole line is pretty exciting. I think, the 1060, the 1050, 20, and the 10 are kind of like the ones that are most interesting for us at Adafruit right now. The 1170s, I think, are still actually quite hard to come by. And of course, like with all these chip supply issues right now, like who knows which ones we'll be able to actually get. But I know we're starting with the 1011, which is this 1010 here. All right, let me answer David's question here. And then let me know if you want me to show the boards off under the camera, or we should actually start testing it. Let's see. I'm just copying the question into the notes. So the question from David is, doesn't the Teensy have a proprietary part like the bootloader, and is it supported where other iMX boards are raw? So what will be the difference for CircuitPython support? That's a great question. You were right. The Teensy, which I have one here, has I don't know which chip it is, but there's some other chips here. Dave says yes to see the boards. Okay, we can do that. Johnny said no. I think we can go through them quickly. I need to get them out anyway and take a look. So here's the Teensy 4.1. I won't show this again, but there is a chip on here and it facilitates loading code. So it won't impact it won't impact how CircuitPython runs after it's on there, but the way that you load onto the Teensy stuff will be different at least the first time. I think our plan might be to, like, there's a Teensy loader, and I think our plan is to, you would use the Teensy loader once to get tiny UF2 on there, which is our UF2 bootloader. And then after that, you'd be able to just use the tiny UF2 to load new versions of CircuitPython on it. So I think that's our plan there. But after CircuitPython's running, it doesn't change. It prevents us from doing like reset, like double tap to reset into the bootloader sorts of things. But on these chips, that's kind of tricky anyway, because all of the iMXs have built-in boot ROMs, which means that like there's code that runs always before you, that is like baked into the chip itself and does like flash initialization, which I think I did talk about last week and what we'll get to maybe eventually today. Okay, so let's just do a quick overhead tour of all these boards. And I don't know a whole lot about them, so it might actually not be that interesting. So let's use some comparisons here. So let me AKA zoom in, and I'll hit there. Sorry if there's dirt on the desk. Okay, so this is let me move these cables out of the way. So I actually have a Feather RP2040 here we can use as size comparison. I actually need to remove the RP2040 stuff from my desk. Like, I'll move it on, at least for a little while. I can't unplug it. It's the cord for the cat cam. All right, there we go. Sorry if it's dirty. I have cats. Okay, so here's the Metro. Bruce says, I guess I should retrieve my iMX box from storage. By that time, Scott will have moved on. So I'm not the only one working on iMX. Jeff is as well. He just found an issue with the SPI being really slow and fixed that. So that's really exciting. Okay, let me get out Teensy's. Oh, and let me switch this to eye tracking mode. This camera, that like overhead's pretty good. You leave it alone. Okay, here's what we got. Here's a Teensy 4.1 and a Teensy 3.0. Oh yeah, maybe we should have had Jeff on again. So my understanding is that these are very similar. I guess the Teensy 4.0 has 2 megabytes of flash, which is this tiny chip here. But then there's a bigger flash chip on the Teensy 4.1. I think it's like 4 or 8. I don't remember. So those are all the Teensys. So these are basically all the boards that I know of. Well, this is an RP2040. But I don't know of a whole lot of people that have adopted the iMX series in dev boards. So all of the other dev boards I have here are actually from NXP, who makes them. So let me put the Teensys away. Actually, maybe I'll set those aside. So one of the disadvantages of the Teensys is that, one, they've got these tiny flash chips. So if I'm debugging flash code, like I'm not going to do it on these because they're just like, I can't use my clip. David says, are you going to solder pins on all of those? No, I don't plan on it. I tend to not care if the pins work. Like, getting the pins working is like the easiest part. It's the flash chips that are a lot more difficult. So, okay, I'll put those away. And let's go through the line. So let's start at the bottom of the line. So this is the 1010. And then maybe we'll compare the 1010 to the 1060. So the dev boards do get more expensive as well. So there's the Metro, and can't quite fit it, but there's it kind of overlaid. And the iMX 1010 here has Arduino pinout, and I don't know what other stuff is on here. I haven't done a lot with it. Here's the flash chip though, so it's like a regular size flash chip, so like I'd be able to use the clip on there to debug. It's got 2 USBs across kitty corner here, and like on anything, most dev boards like this have these like integrated J-Linky sorts of things. That's what this chip is here. So this USB, simply by proximity, I know is going to control the thing that loads code onto here. And then if I wanted CircuitPython, I would want it on this one. Oh, and when was it that I was ranting about this? There's 3 buttons and none of them are labeled. They're just labeled with like their switch number. They don't tell you which one's like reset and boot and stuff, which is outrageous to me. 4 buttons. Miguel says, interesting. Okay, so that's the 1011, and I'm actually just gonna keep these in these bags because they're labeled nicely. So this is exactly like impulse buying for digikey as it's available. So the next step is the 1015, which is almost identical to the 1011 in terms of what it does, except the chip is bigger. And maybe I should show that, but it's the same chip here. So you can see that like the one on the Metro is like smaller. So this is like an 80 pin. This is what's on the 1010. And then I think it's the chip that's the only difference here. And again, we can see that there's like the 4 buttons. There's the Arduino headers, but they're not populated. It's got the same like audio out, which is what that must be for I2S maybe. And then here's the like debugger section, and then the regular output. Very similar. And there's the flash chip here. They're pretty easy to spot. They're pretty chunky unless they're not, unless they're real small. So that's the 1015. Okay. So we're looking for the 1020. So this is a chunkier board, and I should actually know what I did. It's got like these legs to hold it up, but that just means that it takes more space. So I'm gonna actually just unscrew. I'm unscrewing them. They're just these plastic legs. I'll just leave them in the bag. Maybe that's there because there are these dip switches on the bottom, and maybe the legs. Well, I'm sure the legs protect it, but I don't really care. Mark says, I tried Zephyr on it. It worked, so I turned it off again. Yeah, the NXP folks work on Zephyr, so it should be well supported. Okay, sorry, I'm optimizing my space as I go along here. I don't think I got this board actually working, if I remember right. I think that's one of the things Jeff was going to check, actually. And this one is interesting. So, and this is probably why it doesn't work. So check that out. There's 2 giant chips here. There's the 1020. Oh no, I dropped a screw. I dropped a white screw on a white carpet, but I found it. Okay, so let's do a survey of this board, and I think I have to actually zoom out here a bit because the board is large. So what do we have here? We've got our unlabeled buttons, and we've got a switch, we've got power, we've got an SD card slot, headphone jack. So again, this is probably just an audio circuit, and this is probably actually a microphone, if I had to guess. And then there's Ethernet here, and this chip here, my guess would be that it's connected to the Ethernet. So this is like the Ethernet PHY. And then we have this here, which looks like this is probably what the dev kit section is. Again, it's got this like ground post to connect to. So it's probably connecting, controlling this. And now there's this giant chip and then this giant chip. And actually this chip as well. But this one looks like a CAN transceiver because like I think these 3 pins is CAN. So I think this is CAN, and then this looks like a flash chip. And let me see if I can. Yeah, so it's like an 8-bit flash chip. So this is the flash chips we're used to using. But then this is out actually flash as well, I think. But I think it's hyper flash. And hyper flash is, this is either like 8 bits at a time or maybe even 16 bits at a time that you read from. So I think this board is one of them that has these 2 different flash chips on here. And we got a question from Ham's Lab saying what audio codec's on there. I can try to read it off. It's like WM8960G 7CDUPDR. I think. So that's you check the data sheet. They'll say it on there as well. Yeah, so this board is like a lot bigger. No display stuff, which some of them may have. So that's the 1021. Might be SD-RAM. Ah, true, Bruce. That could be SD-RAM as well. You'd have to pull it up and look. But I know that some of these have hyperflash. In fact, so that's the top of the LQFP. And let me take it back out. So there's that one. And that's what, 144 pins? But then after that you get into BGA territory. Pshaw, why look it up when we can guess? Exactly. Exactly, why would I do that? So here is the 1050 version. And look at how tiny, this is the iMX chip here. Look at how tiny it is compared to how giant it is here. And imagine that it's actually like the piece of silicon in here is probably larger on the small one than the big one, because there's a bunch of space taken up in this package simply to break out all the pins around the outside. So if you look at pictures of decap... Oh, I dropped it. Luckily, they're all in bags. Spook's like, what are you doing? Yeah, so this chip is just big because of all the pins that get broken out. But then when you actually go up in the line, you get a much smaller footprint, but the pins are on the bottom. So it's much harder to rework. And again, this one has the legs on it too that I kind of want to take off. Jonah, are you clapping because I dropped the thing? Oh, and let me get the last one. Okay. So this is the 1050. And I'm just going to remove the legs as well on this. Oh, I just remembered I have a PR I should check on before I call it weekend. If I don't end up testing the iMX stuff, that's fine. I should at least commit it and push it. If folks have more questions, I can try to guess on their answers. Okay, so I took the legs off this. And again, I think there's just like a flat flex connector on the bottom. Yeah, so this is for a touch a display and a touch screen. So that's on there if you wanted to add it. And that's because the 1050 adds that like parallel RGB interface. So that's why it's on there. Maybe I haven't actually gotten this out. Maybe that's why the legs are still on there. Okay, let's look at the top. So what do we have on the top here? SD card, Arduino footprint, the main chip, and then this I think is a hyper flash. I remember like the 1050 I think is the thing that they came out with first. I think there's both a like an octal flash and a quad flash, which I think is probably this one. Yeah, that's what it looks like. And then this is the CAN circuitry here again. And then this I think is dual USBs coming from the 1050. And then we have a power supply and a power switch. And going around we have the Ethernet here with this chip here. And then the audio stuff is over here. I don't know what this flat flex is. And then this here is, I'm sure, the like debugger side of things. So this isn't connected directly to this chip. And then you got some dip switches here with different settings. And they allows you to boot like off of this versus that, for example. Very gracefully handled while live on the interwebs. Yeah, I don't know. I think I'm not gonna buy a dev board that's more than like $150. So I don't know what these run for. We could pull it up on digikey here. But they're also kind of invaluable if you were doing work on them. So this is the great category evaluation boards. Bruce says $79. It's 89 here for me. So here's the board that we're looking at. So it's not on NXP's site. It's 79. I just go to digikey automatically. Aaron says, I can't hear digikey without singing the Great Search song in my head. Yeah, and in fact, I don't know if Lamore's actually done this category yet. Maybe that's a good Great Search, is the evaluation boards embedded MCU DSP. I spend too much money probably when I'm making an order and I go in stock, new product, apply all, sort by price. This is my impulse buy aisle, so to speak, of digikey. So you can see like, oh, Picos, like they've got 7,300 of them right now. You can see SparkFun stuff here. You can see Black Pill, and it's actually the Black Pill that we carry. So you'll see Adafruit boards show up here as well. It's always just interesting to see like Nucleo boards are really, really good as well. Like they're clearly subsidized, as Mark's pointing out. You can get the STM32H745 with the screen for the same price. Yeah, but you know what? High-speed USB. Okay, so that's the 1050 board. Yeah, and Adafruit can be out of stock because people like digikey purchase from that. Okay, so that's the 1050. I'm gonna throw it on the floor now. And then last up we have the 1060 board. I've actually had these for a while. Most of this family's been out a year or two. Oh, and let me switch back to the overhead. Actually, maybe we should look up how much does the 1060 EVK cost? This one's just over 100, so it's 112. So what do you get for 112? So this reminder, this is the chip that's on the Teensy. So this is why $20 for a Teensy 4 is like a steal. This chip is really impressive. It's like 600 megahertz, which is wild. It actually looks very similar to me. So we have the power stuff. We have micro SD card. We have, this is a flash chip. It says ISSI on it. This is a flash chip. Actually, maybe it's, I don't know. This might have RAM as well. That might actually be RAM. So what I see here is this looks like a flash chip to me. This says Spansion on it, which it could also be flash, and then this chip is probably flash as well. Indra asks a great question. Why they have Arduino pinouts? It's because of Arduino's influence over the dev board world, right? Like they have Arduino pinouts so that you can have Arduino shields on here. You buy $100 thing, but you may want to try it with like your e-ink Arduino shield or whatever Arduino shield you want to experiment with. It's just, it became such a standard that all of these dev boards have it as well. Like they're hard to spot because the shape's not there, but like I could go grab an Arduino shield and like plop it on there. And at least all the pins would be wired up. So, okay, we have our two USBs here. We have our Ethernet. We have this thing, which I don't remember what it is. That's actually, it's probably camera. Camera is a good guess. I think this is a microphone, audio out. This is for CAN, I would guess. And then here's the debugger circuitry again, and the dip switches. So pretty similar to the 1050. And in fact, we should just confirm that, yeah, it has the flat flex for both the display, and this is for like the touch controller as well. I think that's usually what it is. So yeah, that's the if you wanted to buy what NXP releases for testing their 1062 chip and all of the others in this line. Although I guess I'll show you 1170 EVK. Let's see if they have that. Yeah, so it's $180. So this is the gigahertz thing. They do have 12 in stock, but it's just like so far out. Oh, sorry, you can't see. So this is the dual core 1 gigahertz version. It's $180, and it's like definitely above my impulse buy for dev boards. But it would go with go in this box for sure. All right, we know Mark is advocating for STM in the chat. We know Mark likes STM. But yeah, these can do screens as well. They just don't have them sold with them. Okay, so I'm gonna put that away. And maybe what I want to do is figure out, actually, let me check on the pull request that has been approved, but it was crashing. And maybe we can get that in. But I don't need one. Mark says, just say to Lamore you need one, and then she'll send me one. I mean, she wouldn't send me one. She would just say order it and bill us. They would pay me back for it. But it's just not like... We have plenty to do in this family before we get to that point. Okay. Yanni's pointing out, well, now some prices could be higher than they normally are. That's true. I just want to check a PR. Let me just bookend this iMX stuff with... Oh, man. It's like 20 seconds fast. Okay. So I've been working on switching CircuitPython over to the nvm.toml stuff. And I think I talked about it already. Jose David, thank you for joining. We've got like 30 minutes left or so. Okay, so here's the PR that I want to check on. And then I also, so the one for the RP2040 was merged in already. So if you're on Windows and had trouble building like Lemore, we did get a change in earlier that fixed it. So there's that. Here's the spy fix that I was talking about that Jeff did, and a couple other fixes. So thank you to folks there. A fix. Oh, so there was a fix to one of the. There was a fix for one of the flash chip settings, and Jeff like filed an issue on the nvm.toml stuff, like say fix it here too. And so I was finally like, oh, I should just get everything, all of our flash definitions in CircuitPython switched over. And so I did. So this got merged on Monday. So this is the PR to switch the RP2040 to the nvm.toml stuff. Yeah, Paul says, hi, Scott. I was late. Didn't know that USA had the hour been changed. Yeah, sorry about that. I think it was like a week or two ago. We switched earlier than the world because we can't decide when we want to do it. Spy gaps, very technical. Yeah, if you look in that, you'll see that it's like a byte and then a pause and a byte and pause and byte and pause. And it was because there was like some delay settings that were set that didn't need to be. Okay, so we got the RP2040 flash settings merged in, and then I was like, all right, I'll just switch everything over. So this patch here switches the external devices stuff that's shared. Oh, good, you went for a run. I should have gone for a run, but you know. And yeah, heads up to folks outside the US, you're probably going to switch time, but we will not. So just be aware of that. So this change here that looks ready to go, let me just triple check it. I just renamed some of the WinBond chips, so that's what these are. But we have this like shared system for external flashes for boards that just use a regular QSPI device. The ones that do execute in place, the RP2040 and the iMX, have to do it themselves. But this is the stuff that uses it just externally just for the flash file system. And I was like, all right, I'll just move it over. So the way that I moved it over is just like we used to have devices.h, and in there it had like all these defines. And so now I just generate that file based on the nvm.toml. So it won't do any like detection of flash sizes and stuff, which would be nice. But at least we'll be all on the same page in terms of like flash settings. So I had to split it up. So here's just device.h, and this is the struct it generates. This deleted file is the old version. And then now we're doing a Jinja file. And the Jinja file has a for loop over all the devices and just dumps all the settings in the same format. And just had to fix some includes, change the make file a little bit. And here's the quick Python script that just runs the nvm cascade toml stuff and then generates the file. So that's that. It had a number of problems. Oh, and Jeff said that's a better fix than what I proposed. So we had a couple problems getting it to build. Jinja, Jinja, not ginger. Yeah. So it's all ready to go. So I'm going to merge it, which will be exciting. So the last up, the only place where we have flash settings now then is on the iMX. So RP2040 is switched over with this change. The thing that I just hit merge on switches all of the other ports except iMX over. And so now that gets up to speed, I think. we're no longer shopping on digikey. And we talked about the part stuff already, so okay, let's let me clean my desk up a little bit. I'm gonna unplug the Celia stuff. This socketed RP2040 is going away. And oh, you can't see my overhead. So I actually just have like a bin back under the monitor here that I'll just throw these stuff in. So I'm done with this. There's the prototype RP2040, so we're done with that. I do have this clip that's really useful for debugging that, so I think I'm gonna leave that. Leave that there. So those are gonna go in the box. Oh, and I have this Teensy 4.1. What do you think the odds are that my code for iMX just works? Let's leave it 1011. Let's get this going. Let's figure out how this works again. So I have used this in the past, so it's possible. It's possible it probably has CircuitPython on it already. It's not a new board. So let me switch to. Do I need? Oh no, I don't have another. Micro USB cable. I've got to have another one. No, this is USB-C. This one's USB-C. J-Link I don't need. Sorry, I should have thought about this. Do I have one of these? Oh, the RP24 micro mod. No, I don't. I have some of the other micro mods though. I have this sensor thing that I've been designing. There's a micro mod on this side of it. But I have the NRF ones, not the RP2040, and it's actually like I'm a little late here. Oh, you can't see.
Where in the world is that part I need? The great search with digikey.
Yeah. Oh, don't play again. Sorry, I should have done that. Oh no, what is it doing? Okay, sorry. I just thought that was fun. We did our own great search. The code works. Now it's stuck in Mark's brain. Okay, so the problem is that I have a micro USB cable, but it's plugged into. I have two on my desk, but they're being used, so I need to find a third one. I think that's where I'm at, because I want to try this. So, actually, let's just push this code. So in my branch here, I've got this iMX flash thing. And let me see. Mark says I woke up one night to having the Ion MPI full extended version stuck in my head. Let's see if the iMX EVK compiles here. So iMX RT 1010 EVK. Clean. So I might have versions of it. Then we'll build that. I was working on something else when that started to play and I immediately started singing along. I do too. Okay, so it didn't work. Okay, this is perfect. So let's actually add a definition. It looks like this is a flash chip that I don't have. So this is probably better. This is more entertaining than waiting for me to find a USB cable. So let's just get it compiling here. And this will actually be perfect for showing how to add a new flash chip to the nvm.toml. So let's do that, shall we? So I'm going to hit the timecode thing, and then I'm going to adjust it because it's not going to be quite right. So 29:50. So now I'm 30 seconds behind or ahead. That's kind of weird that the clock is that wrong. Okay, so what happened here? We tried to compile, and the flash device that we thought we needed is the AT25SF128A. And it says list index out of range, which is a terrible error message. But actually, we could fix that too. So if we say, let's see. Sorry, I make all my windows tiny because I know that they're going to have to be smaller than I normally have them. Okay, so do I have it open already? I do, and that's what's up. So what? Oh, here we go. Length of skews is 0. We tell you to set that. But we should also check the length of flashes. One might say terror message. I don't know why you're getting all those Uncrustify things. It should be all up to date. We did run Uncrustify and everything. Or at least we thought we did. Jeff and I fixed it last week. So let's just say unknown flash chip. And we'll just change the exit code. Oh yeah, Mark is pointing out that the black pill has nice curve traces. Yeah, I'm excited for, where is this? Line 44. I thought I just added a thing that, oh, flashes NVM. Okay. Oops. All right, well, that's helpful. So now let's find the datasheet for this flash chip. Oops. Some of my programs are Control-C and some of them are Command-C, and it's the worst thing ever. Gadgetoid says, I ran pre-commit run all files locally so I can stop embarrassing myself by pushing white space errors. That should work, I think. But I don't think you need to, because pre-commit should run on just the files you're about to change. Like when you do git commit, pre-commit should run and check just the files that you're changing instead of giving you all those other ones to change. Okay, so look at that. First entry here is an Adesto Technologies datasheet for that chip. So let's open that up and we'll take a look at it. And we'll also, let's dig into nvm.toml here. We can see Flash, Adesto Tech, and we can see we've got AT25DF641A, 041A, 161.toml, and 081A toml. So what we should do is probably sector protection changes. So let's duplicate. And I'm going to just move it off screen while I copy what the... It is an AT25SF128A. Okay. And I don't know why my browser does this. So there's these comments that I'm just going to delete. I have a feeling it's a 128 by 8 is what? 16? Yeah. Yeah, so it's a 16 megabyte flash. So if we start thinking about what to update here, total size would be 1, 2, 4, 8, and then 16 would be an extra 1, I think. That's right. And what we want to do is now look at here. So memory type is actually in device identification, which is, I think, this 89. Does that make sense? So it does a 9F read. So capacity is 01, which is not correct. Oh, interesting. It's only not correct for 9F. It is correct for 90. What? What commands are these? 909294 and AB. Huh. So that's interesting that it's just wrong for 9F. That's what capacity here matches, is the 9F. So we want to leave that. And memory type is the second one, I think. So we're going to want 89. And then we have to figure out if it has sector protection, which I don't remember. It doesn't actually matter. Just looking at security instructions. I'm going to say no. I'm just going to put no here. I suspect that the sector protection is a like old flash chip thing. Okay, so there's that. And let's just double check these other things. So there's the 1F that we saw. Let's just actually copy these in, and it might be kind of a pain to, but I suspect this is a newer chip and we could probably do better off with it. So start time microseconds is 10,000, which I suspect is, oops, probably, so I think it's usually in power up timing. So power up timing here, there's this like TVSL here is 300 microseconds, but then there's this chip select not allowed, which kind of hard to tell. I think we could just do it at 300. Again, this is something that's actually not used, but I'm gonna write that 300 in there. And then what I have to do, and the ones that changed, let's leave there. What we have to do is we can't have one at the top and then one down at the bottom. Like we can't have like a default value. We have to, like, if we're going to change a value, it has to be changed at the same level across everything. So max clock speed megahertz, and this right now it's not per command. So we can see here that like there's a 70 here for regular reads, and so that's what we're gonna have to put. And then there's this quad enable bit mask. So this is going to be in product overview. There's usually a status register thing that tells you. Here it is, status register table. Okay, so quad enable is in the second status register byte. So this is really common. So it's 2. and it's also in the second. So these are the values we got from the top. So that's the same. And then write status register split. So the question is do we have instruction descriptions? So write enable for, yeah, so there's this 31. This is the split write that we would need. So that is true. And now we need to know, can we do a 6B quad read? Which we can. And there is a dummy byte, which means that it's 8. So that is true as well. And 32 QSPI write is this quad page program. And it can do that as well. So pretty neat. And unfortunately now what we have to do, because we have this kind of rule about what is at the top, is that I think all but manufacturer we changed. Right, so there's 1, 2, 3, 4, 5, 6, 7. Is that right? Yeah. 7 there, 1, 2, 3, 4, 5, 6. Max clock speed, quad enable. This enable status byte 2 is correct. Okay, so these 6 settings we have to move to all of the other flashes under here, unfortunately. Because we've changed it at that level in for the new chip. And I wonder if I got one of these. Actually, I shouldn't have closed that. Let me pull it up again. So I'm just curious if I actually have one of these chips. I mean, besides the one that's soldered down there. I have this ATQF. I don't think I got maybe any that were that big. SF161. I do have some others, but not that large of one. So we'll see. Okay, so that's all set. And we configure this, what we think is correct. But I think that there's also, let's see, what other things? So there's this template file, which is really handy. So maybe we want to set some of these as well, since we're looking at the data sheet here. So continuous status write, we can read up on, we did the quad enable status bit, and the E7 quad read is, I'm curious as well. So let's look at, oh look, it has E7 and 4, and then dummy 6, which is, what's 6 say? So it's got 2 dummies here. Which is correct. So it does have this quad word as well. And then continuous status write. So what we want to do is we want to look at the write status register 01. And here it could say in byte 3 that we could do the second byte's worth of stuff, but it doesn't look like that's the case. So I just want to triple check, because the WinBond says like, oh, like, if you happen to give us the second one for backwards compatibility, it's okay. But it doesn't look like it. So it says the write status write status register instruction has no effect on these bits. CS must be driven high after the 8th bit of data byte has been latched in. So that means that like you can't do 16 bits. So the answer to can I do continuous status writes, meaning can I write 2 status byte at once, is false. So that's correct. Okay, so we've defined it, and we should now be able to build with that definition, except something happened. So let's take a look. Oh. None undeclared. That's suspicious. That sounds like a Python-y thing linking through. So let's figure out where that is. It's in read SDR line 102. So let's pull up the template. Here, and line 102 is quad enable status byte, which I thought should be 2, but it's none. Did I remove it accidentally from here? Yes, I did. Quad enable status byte equals 2. Okay. So let's see if that... Oh, and it probably needs to... It's not smart enough to know the dependencies. Any final questions? We got 10 minutes left. Computer's hot. And it's compiling. Kicking up the fans. Okay, it worked. Great. My guess is that some of the other ones will need that as well. So in the last 10 minutes, I think I actually just want to get this committed. I'd like to commit to GitHub to just simply have it backed up. And I realized that my YouTube was covered over. So let's say git status. Let's get the data stuff checked in first. Git add, git commit. Actually, let's pull in case all right, already up to date. Add a flash from iMX RT 1010 EVK. And then we're git statusing, git push, origin main. I'm bad. I'm not doing reviews yet on the nvm.toml stuff, even though I probably should. Okay, so that's set. Fede2 says, if the Teensy 4.1 in the future will be able to run CircuitPython, will Lady Ada move the testers to CircuitPython? Would be cool to have CircuitPython hardware testing CircuitPython hardware. So you can run CircuitPython on the Teensy 4 now. We've actually had support for it for a while. Arturo did the initial support, which is really great. But it's out. This work I'm doing here is just to like change the way that we do the flash settings. The older way worked just fine. It was just like not centralized. And so when Jeff came up to do the Metro, and the Metro had a different chip now than it did before, like then he was like, oh, it would be really nice if we just use this nvm.toml stuff for the chips. Anyway, yeah, and the thing that the testers use USB host, which we don't have for CircuitPython. So maybe once we have that. But yeah, speed too. Speed is important. Okay, so let's see what we've got here in our changes. So the other thing here is I'm making another repo. So let's do that next. So ports, iMX RT flash config. So this is actually a separate thing. And I'm just going to add that all, git commit Official version. And I should put a README and a license file and a git ignore. Dang it. Dang it. I don't want to... This PyCache stuff I definitely don't want. So let's do git ignore. And I think it's PyCache. That should be enough, right? Git reset. I don't know if I can reset. That was the first commit to the repo. So I don't know how that works. So I think what I can do is I can do git remove templates PyCache. This file. And now there's this thing stage. I could do git commit amend. And now I can see it's only adding the files that I actually want to add. Okay. So now I need to make a new repo. iMX RT flash config is what I'm going to call it. So I'm going to go to Adafruit and do git Adafruit, GitHub Adafruit, new iMX RT flash config. Simple script to generate iMX RT flash config structs based on nvm.toml. Oh, and I thought I needed to add the path in there. So that's good. Create the repository. And now there's nothing in it. So now I copy it and I do git remote add Adafruit, that link, and then I can do git push Adafruit main. And now we should see, oops, this will go away. And now we have the files. And the reason I'm doing this as a separate repo is that I'm going to use it in tinyUF2 as well, and maybe even tinyUSB. TinyUF2 for sure to start with, but tinyUSB might need it for the examples. Okay. So that's there. I should add code of conduct, readme, that sort of stuff. But for now, since I'm just trying to get all my code checked in, that's okay. Now I have to do this weird thing, because right now I just made the folder and then I git initted it, but I actually want it as a submodule. So I'm actually going to remove that folder, which is a little scary. But then I want to do git submodule add branch iMX RT flash config. And then this is actually almost right, I think. HTTPS github.com Adafruit iMX RT flash config. Haha. So now it should add it as a submodule. So you can see that it modified the git modules. So git modules is what tells you like, oh, this folder points to this particular repo. And then the file itself tells you what commit it is, I think, is the way it's done. And you can see there's a bunch of changes here. And so what I'm going to do is I'm just going to add those. I might rebase them later. But for now, that's fine. Builds okay with submodule. This is not ready to PR yet, but at least I can push it up to my stuff. And I think it might ideally it would run the CI, so it would tell me all the other ones that I broke that need flash definitions. Let's just check that out. tan/Circuitpython. And this here. And let's just see commits. Right, so start refactoring. It did fail 7 checks here. So it failed all the EVKs. And it failed the Metro. I think it failed everything, probably. And it failed the feathers. Did it not fail the Teensies? That's funny. It's probably just not listed here. But yeah, that'll be interesting to see how many of the boards are building as is right now. And then the next step is to actually make sure that it works. Minor thing. But definitely making progress. Are there any final questions? Neradoc says, I would have run the git module add without deleting the directory. That was scary. I could have changed the directory and done it, but I wanted to make sure that it was like not... I don't know if add works if you already initialized the git repo. And I was pretty confident that it would work because I had like looked on GitHub that the files were there. But yeah, it probably would have been smarter to move it, not delete it, to get it out of the way. Yeah, so that's about it. We could just see if the other boards build. I'm a little bit interested in that. I'm excited. Everyone's excited about BLE. Oh, Neardoc says it should have worked without even moving it. Oh, I didn't know that. Let's see what works here. Feather, M7. 1011 clean. Whenever I have to delete something or move it weirdly, I always back it up first as I don't trust myself. Yeah, like I feel like I usually back up to GitHub, so that's kind of the way it goes. Okay, that one works. iMX RT 1011. Some of these are by Adafruit and some of them are by Arturo. Devo says, is that Chrome web browser you're using? I use it for video chats, but other than that, I use Firefox. Oh, good night, Dave. Coffee's wearing off now. Time to hit the sack. Thanks for hanging out. It's always fun to have folks watching. Okay, that one worked too. Let's see if the 1062 does. I bet it's just the EVKs that are going to be a problem because they have weirder chips. Oh, that's interesting. A warning about cast alignment. That's using a different copy of the driver, so that might be why. All right, let's list boards again. So all the feathers built. And iMX RT 10. We did the 10, so let's do the 1020. Unknown flash chip. Okay, so that's not surprising. So the 1020 doesn't work. Let's see, the 1060 probably doesn't work either. Time Machine is a low effort backup that may or may not work. I trust my manual backups, I do, and I trust that when I move to my NAS and let it handle the backups to external drives. What do you use for the deduplication, versioning, and compression? I was planning on moving to ButterFS. Okay, so there's another flash chip that we don't have for the 1060, which is not surprising. The Metro should work. Metro M7 1011. Clean. Maybe I just do it. It's built in into Synology. Yeah, okay. Okay, so now we just have the Teensies to build. I think Synology doesn't use BetterFS. I think they said like, oh wait, ours is better. All right, so there's that error again. If we only have 2 to add, maybe I'll just do it. Do it now. And in fact, there's this other repo called the raw. Yeah, maybe we just do it. Okay. So I actually, where do I have it open? I have so many windows. Okay, so here's the data sheet. Let's do this. Let's save page as, and then I also have repos, nvm.raw. So this is where I'm just collecting all of the stuff. So let's do Adestotech, new folder, and then that's exactly right. That's what we want to call it. The same, like the SKU name there, and then we're gonna want to add a datasheet URL. I'm trying to collect everything in one place, you know. New file, at25 sf128a.toml. And let's figure out how we can get that. So how do we find this data sheet? Oh, I think we just searched for it here. Adestotech. Who knows if that's the newest version though? Let's actually find it from the manufacturer. So if we go to Adestotech, and I don't know why Brilliant is the first page, but products. And what if we just search for it? AT25 SF128A. Oh, wow. Well, interesting. It downloaded a datasheet that's 1.3 megabytes bigger. Oh. They had to tell you that they were purchased by Dialog. Let's see if the usually at the bottom there's a revision history. So here we can see added a part number, an ordering code, and 121. So likely this other version that I just saved is out of date. Not that out of date. F versus, yeah. So it's interesting that like this is a perfect example of why I want the URL in here too. So let's save page as, and we'll just save over it. And it's kind of unfortunate that like we just searched for it and we clicked it. I don't know how to memory. Maybe if we click in here, we'll find a. So, ooh, this is interesting, like product families. Driver reference package. So they don't really have a great, let's see, what does resources? Application notes. Layout guides. Like none of these are really a great. Not a great place to be like, I want to go back to where it was. Oh, and it's on Dialog now too. Maybe it was before. Products. All right, well, we just searched for it, so I guess I'll just... What was the other thing I said? And I think Renaissance bot dialogue. Joe Gold says, URLs change all the time and manufacturers do not always preserve product datasheet URLs. Yeah, totally. That's why I actually have, I have a second one that's like, where do you go to get the URL to the datasheet? And that's also why I copied the PDF, right? So in this WinBond, I had this datasheet link URL. So let's just call it that. And I hope folks like who are doing Flash things actually like are interested in, how do I find the link? AT25 SF128 search products. A. Weird. If I open the network panel, can I see where it's downloading from? Network. Oh, what is this? Adesto memory for... Let's see what this is. Oh, look at that. There's a URL. Copy. Okay, so we'll put that in here. Even though it probably is not probably won't change with the revision. But that's okay. I'm curious what this other Adesto memory for NXP. Oh, look at that. It's like specifically for the RT MCUs. Huh. Free EVK refit available. So they'll like swap it out for you? That's pretty wild. All right, I'm over time here. But yeah, I forgot to do this bit of it. So good. I think that's fine. And the question also is like, do we rename this Adesto Tech to Dialogue, or even like Renaissance if they bought them? But for now, I think this is fine. So let me just I'll commit that and push it just so that everything is backed up, like I said. Mark says, these streams motivate me to work. I got audio mixer for the RP2040 PR'd. In theory, should work for any non-M4 too. That's awesome. Thank you, Mark. People will be excited about that. Add Desto Tech info. Alrighty. Well, it's been a pleasure, everyone. Let me switch to the camera and take a final time code. Even though the clock here is going to be wrong. I need to use an RTC for this. I don't even know why. Wrap up. Thank you, everybody, for joining me on this deep dive. Next week will be on Friday, as will be the week after that. And the Friday the week after is Open Hardware Summit until 2:30. So I'll just like leave that a little bit early. I will be presenting in the morning at like 9 o'clock my time. And it will also be our 1-year anniversary. So if you have things that we should do to celebrate 1 year of me consistently streaming, let me know. I'm open to ideas. I think that would be fun. And, I don't know. Besides that, yeah, going skiing tomorrow, which should be good. As always, if you want to support me, go to adafruit.com and purchase any hardware that you see there that suits your fancy. If you don't know what you do with it, check out learn.adafruit.com. There's lots and lots of tutorials on how stuff you can build with adafruit.com stuff. That's kind of our marketing. And if you want to check out CircuitPython, go to circuitpython.org. If you want to chat with us all week, feel free to join us on the Adafruit Discord server at adafru.it/discord. That's where you can find me and a whole like tens of thousands of others, although I don't know what are active, thousands at least active folks there. I think that's it. Check out for more iMX improvements, primarily thanks to Jeff. And hopefully next week I'll be on the BLE boat, just wrapping up this Flash stuff, and then it will be BLE workflow, which I'm excited about. I'm doing a kickoff meeting on Tuesday with Trevor, and I remember folks wanted to have Trevor on here as well, so I'll let him know that there's a demand for that. So thank you as always. The cat is licking his butt. I'll pet him after that. That's the beauty of cat cam, right? All right, well, I don't need to pet him. We don't need to watch this. Thank you all. Have a great weekend. Try CircuitPython, support Adafruit, and have a great weekend.